Welcome back, Science 8. We are going to continue Water Quality Part 3. Now, I want you to think about what we learned in the last class a little bit. We learned about several tests regarding water quality, or instead of test, how can I say, some of the property that people are looking for regarding water quality. One of them we talked about was salinity test. The one that talk about how much of dissolved salt, aka ions, present inside of the water. If we have a lot of ions, a lot of salt if you will, ionic salt, we call it hard water. On the other hand, if you don't have a lot of salt, we call it soft water. In Alberta, we drink a lot of water that has sediments inside, and then due to sediment that is being dissolved by a universal solvent, H2O, water naturally have a lot of ions in it, salts in it. So it causes a lot of blockage of the pipe because those aggregate together, become solids, and that in the end have a lot of pipe problem because of less volume, which means less water that is moving back and forth. We're continuing our lesson from where we left off. First thing first, have you wondered how we can clean some of those nasty buildup of sediments that you see on the tile or between the tile? Answer is pretty much visible in this diagram. We need to use vinegar because films and scales that is building up on the tile and fixtures are theoretically one of those negative effects of a hard water, which are sediments. And some of those sediments, including sediments water or a sediment that is being solidified, they are somewhat basic. Base solution means it's opposite of acid. But if you think about why people use vinegar, well, vinegar is a weak acid solution. One thing that a lot of people in grade 8 may not know is if there's a base solution that meets acid solution, they undergo neutralization reaction, which make solution turning into neutral level. During that process, some of those buildup that you see on your tile, they will be dissolved and disappear. So that's why acid is what people use in order to get rid of those buildup. Other parts. This is something that I also have observed in shower booth in Alberta. Here, can you see in this diagram that there's a foggy part, if you will? Even though there's no water that is being turned on inside of the shower booth, well, we call it spotting, and the various white spots on glasses, those are again buildup of sediments, iron, and salt on the glass surface. What do we clean it with? As I said, vinegar type of solution work because it is a weak acid, and those solidified sediments and salt, they are more slight basic. So weak acid, weak base, neutralize together. Sometimes hard water's negative effect is not always on a infrastructure of your bathroom, like tiles and shower booth, glasses, mirror, if you will. There are some clothing damages too. So some of the symptom of hard water on clothes, it weakens some of the fiber, causing tears, soil buildup on clothes, doesn't wash away well, white and gray streak, which you find it quite often if you wear your shirts more than about 2-3 years. And dinginess, graying or yellowing of fabric, discoloring if you will, stiff, harsh to touch fabric. It's kind of like sticking out like a porcupine style, if you will. It doesn't hurt. These are all of those negative effects that can happen for clothing. So less effective when it comes to clothes washing from lack of suds. All right, let's move on to a biotic factors. I want you to think about any type of organism that may present in drinking water, but it's microscopic, which is a way of referring that you need a microscope to see. It looks like invisible from our naked eye. The answer is there are bacteria, various bacteria. You guys hear about E. coli. E. coli always happen a lot in the produce area like lettuce. I think if it's frequent at least once a year, I think in Alberta, there's always massive lettuce recall due to E. coli and infection, if you will. E. coli is a type of bacteria that can cause sickness, and it can cause death too. So some of the common symptoms is little fever, vomiting, stomach cramp, diarrhea. Those are the common ones. So we gotta somehow kill those germs, in this case bacteria as an example, to prevent these organisms infect human body system. We call those filtration specific biotic factor filtration system as water treatment processes. Sometimes people put some chemicals like fluorine and chlorine to kill some of those germs. So, what kind of other water quality testing can we look into? We talk about salt level, salinity test. Also, we talk a little bit about the biofactor related by going through water refining process using chlorine and fluorine. There is a simple filtration that a lot of people overlook sometimes. Like for example, people used to use groundwater, well water if you will, or using a well. People used to draw those water from the ground level and use it as a potable water. And how that happened is because land had several layers of sediments, soil zone and intermediate zone. During that soil zone to intermediate zone, there's a humus layer, organic layer, all the way to soil and sandy layer. By going through each of those sediment, there is a filtration process happen naturally. So if you think about that to the other way, water comes from deep underground that's generally protected by most of the pollutant due to that thick sediments area, and it is not only natural but also a human can use it. Still, I recommend for boiling, similar to pasteurization, to kill off some of the bacteria. So filtration process of fresh water and chemical treatment have to happen at the same time. So filtration that I put over here, it's more about physical approach, and chemical treatment like the word suggests, like chlorine, fluorine, those kind of things are example. Those are chemical process, and these two have to happen simultaneously, which is a big word of saying it needs to happen at the same time, or those two have to be done. And those are significant to increase the level of quality. So let's think about some of those criteria. Number one, taste and odor. For example, if your water has sulfur content in it, an example that I put is hydrogen sulfide over here, then you will have your water smell like a rotten egg. So let's think about some of the tests in here. Sour, acidic, sweet, salty, bitter, mouthfeel. And if it goes a little bit in detail, earthy, chlorinaceous. And if you think about that, think about pool water, some of the grassy or sulfurous, vegetable floury, fishy, alcohol-like, petrol type of smell. All of those are, how can I say, water tasting wheel. And that's just one step. I don't like to represent taste and odor check as the very first criteria and the only criteria. However, it's one of the easiest way to check, especially odor portion, not necessarily taste portion. This second one is something that I wanted to emphasize quite a bit. Turbidity test, which talk about how cloudy things are, how clear things are. Brown water cannot let sunlight penetrate deep enough. Clear water, yes you can. So if you look at the device over here, it's called Secchi disc. This disc is actually reflective, so light can travel through, some of them reflected back, and we are trying to detect how much percentage of light that will return. And based on the water content, if you have a clear water, then a lot of percentage that return back to the surface will be almost close to, well, not 100, but let's assume 100 as a maximum, close to 100. On the other hand, if you have a lot of algae, if you have a lot of brown water, because it has a lot of organic compounds inside, then, well, turbid water will have low percentage. And that really depends how polluted the water is or how brown the water is. The third content, ladies and gentlemen, it's everything about toxic substance. So how toxic things are. One of the good example to talk about this toxicity is these green film that you see, which we call it as a phenomena, algal bloom. That means harmful green algae such as cyanobacteria, blue-green algae that produces toxin covers the whole surface of the freshwater, ocean water, depending on where it is. It thrives also. It also raises the temperature that speed up the algal bloom more and more. So it's a catastrophic event by another event. Long story short, it detects chemical level of toxic concentration, and we are checking those. The fourth one we talk about this bacteria, or in this case any type of microorganism test. Normally, few things: boiling, and some of those chemical, let's say chlorine, fluorine, kill those. So the way that we test this, we gotta use microscope, but boiling, chlorine, fluorine, these chemicals generally kill it. Obviously, you don't want to put a lot of amount in there. There's very small ppm, ppb level. The fifth one, as you can see from this nasty pipe buildup over here, is talk about hardness or mineral content. Remember, Alberta has a lot of sediment, which means a lot of salt and ions, metallic ions, that is being dissolved inside of its water. hard water can cause this pipeline issue. As I mentioned to you, that flow rate will go down as a result, but the pressure itself will build up, which can cause a significant problem when it comes to a winter season below the freezing point. The other one is pH test. pH level that talk about if something is acidic, neutral, or basic. So let's think about these levels a little bit. First thing first, anything acid is when the pH level is below 7. 7 is perfectly neutral. And there's weak acid, which I like to say about 4, 5, 6 area, weak acid. And there's 0, 1, 2, 3, strong acid. There's strong acid that vigorously react like sulfuric acid, and weak acid like vinegar, which is acetic acid, ethanoic acid, sorry, vinegar. It reacts slowly or with diluted situation even. It's going to react even with extra time. On the other hand, if the level is 8 to around 10, 11-ish, we call it weak base, and those are what you have been seeing in the images like sediment buildup, those kind of thing on a tile and so on. You can consider those as a weak base. And we have something called strong base, very strong alkaline. This chart plays such a huge role from now on, especially in grade 9 too. Like I said, the guideline, pH smaller than 7 is acidic, more than 7 basic, and most tap waters are very slightly basic because it has few ions in it, especially in Alberta, hard water. And pH around 7, what we recommend. For today's lesson, that was it. All you gotta do is now is go to textbook page 347, and I want you to do all question on that page.